So again, this number here should be 10 to the 4. So there's correction to this one. So next we're gonna talk about, okay, what happened if we have multiple charges, right? This is force between two charges. It's fine. You use like Coulomb's law and then you just follow this procedure. There's no problem. So for multiple charges, we're gonna use what we call the superposition principle. And this is a very familiar name, right, to all of you because we talk about this concept when we talk about interference of wave. Remember what superposition principle is? In the context of wave, we say that when we have two waves, you just add them together. And remember the reason behind this is because the wave equation is linear. So that means if you have one wave, one valid wave, and you have another also valid wave, when you add the two waves together, the resulting wave is also a valid wave. Okay, so this is what we call superposition principle in wave. In electrical stuff, the superposition principle works like this. So remember, if we have a pair of charge, that's not a problem to calculate the force. So let's say we have Q1, which is positive, and then we have Q2, let's say it's negative. So if we just have these two forces, right? These two charges, let's write down or draw the force on Q1 and Q2, right? So again, the force between the two charges gonna point along the line joining the two, away from each other or towards each other, depends on the polarity. And we know that they are opposite polarity, so they attract each other. So the force on Q1 will point this way. So this is what we call F12. And then F21 will be pointing this way. And then you can use the Coulomb's law to calculate the magnitude of the force, right? But this is the direction of the force F12 and F21. What happens if we have the third one? Let's say the third one is here, and this is also negative, but it's negative Q3. So now you have to pick a different pair. Q1 and Q2, that's one pair. But since you have Q3, you have another pair of charge that you can draw in terms of the force, right? So the superposition principle says that if you have F12 acting on Q1, then you can also draw F13, which is acting on Q1, but it's by Q3. Okay, so Q1 and Q3, they are opposite charge, opposite polarity. So this one and this one also attract each other. Attract each other means F, in this case, 1, 3, because it's F on Q1 by Q3. And you also have F pointing this way on 3, so that's going to be F 3, 1. Okay? And then don't forget that you also have another pair, which is Q2 and Q3. So if you draw the line joining together, now Q2 is negative charge, Q3 is also negative charge, so they have the same polarity, so they have to repel. Okay? Q2 and Q3 repel each other. So that means the force, okay, just think about 2 and 3. Forget about 1 for a moment, just 2 and 3, they repel each other. So that means F, this one, what should I write here? This one should be F31 because it's F on Q3 by Q2, not Q, not 31, 32, right? F32. And then this one we also repel. This one is F23 because it's F force on Q2 by Q3. Okay? Make sure you understand everything in this picture, why this vector is pointing this way, why this vector is pointing this way. Okay? It's very important because once you get this, everything else that follows is going to be a lot easier. All right? So, the superposition principle tells you that F12 and F13 are two forces on Q1. So the net force on Q1 are just F12 plus F13. So I'm gonna write it down like this. Net force on Q1, which we will call F1, is equal to the summation of every force acting on Q1. And in this case, we have two of them, which is F12 and F13. This is the superposition principle. It's actually not trivial why this is true. Okay? We kind of learn in elementary physics class that this is true, but it's true because the equation governing electromagnetic theory is also linear. The same way that wave equation is linear in wave, so you can add the two waves together and you're gonna get the resulting wave also. This is the same principle. The equation governing electromagnetic theory, it has a name. It's called Maxwell equation. It's actually equations because it's not just one equation, there are actually 4 equations. So it's a set of equations. Maxwell equation is linear. It means that if you have one force and then you have another force and then you add the two together, the resulting force still obeys Maxwell equation. That's what we mean by linear. So the linearity of Maxwell equations allows us to say that the force can be just added together. Okay, which is very good because it makes everything a lot more convenient in this sense. Okay, but anyway, we're not going to talk too much about how exactly Maxwell equation is linear. The only thing that we need to know at this point is that we just need to add the force together to get the net force on Q1. Okay, so let's do that. So I'm gonna copy this diagram, and then instead of drawing the force on each charge separately, F12 and F13, I'm gonna add so that I have the net force on each one. Okay, so what I mean is this. Looking at Q1, there are two forces acting on Q1, one from Q3 and the other one from Q2. which is this one and this one. So the net force are the vector sum of the two forces. And this is very, very important because, believe it or not, you think you understand now, but in the exam you all forget that the force is vector. So you need to add them like you add vector, right? You cannot just add the number together. You have to care also about the direction. So in this case for Q1, F13 is pointing that way, F12 is pointing that way. What is the resulting force then? The resulting force is when you add the vector together. So you get this one as the resulting force. This is what we call F1. Okay? According to this equation, F1 is this one plus that one. So I can maybe erase this. And if you want to know, then you can refer to the diagram above. Right. So that's the net force acting on Q1. What about Q2? It's the same thing. For Q2, the force acting on Q2 has to be the sum of all the forces acting on Q2. So in this case, there are two of them, F21 and F23. And you have to add them again using the proper vector addition method. So in this case, it's going to be this diagram, and it's going to be pointing that way. Okay, so clean this up a little bit. So the force is going to be going that way. So that's going to be F2. And then I'm going to erase this force. Again, if you want to see where it comes from, look at the top diagram. And then F3 is the same thing. F3 is F31 plus F32. So F3 is pointing in this direction here. Again, a vector sum of F31 and F32. And then I erase this. And there you have it. The force acting on each charge in this system. Okay, again, make sure you understand how I got these total net force on each charge like this. So you can see how you can build upon this principle to calculate the force on many charges. So let's do an example where we really put in the number. So let's consider 4 charges, and they are arranged at the corner of a square. So let's say this is an example. So we have Q1 here plus Q1. Let's say this is 1 microcoulomb. Actually, the plus sign should be in the number. So it's plus 1 microcoulomb. And then the second one is here, Q2. Let's say it's minus 1 microcoulomb. And then it's a square, right? So they should be here. I need one more down here. This is Q3. Let's say Q3 is minus 2 microcoulombs. And then Q4, which is here, is plus 1 microcoulomb, like this. And this is a square where the length of the square, let's say, is 1 centimeter. Okay, I just made this number up. So this is also 1 centimeter here. Okay, so I mean, just to make it less crowded, let's not write that, but you know that all the sides are equal, which is 1 centimeter. So let's find out what is the net force on Q2. Okay, a very simple question here. What is the net force on Q2? So you have 4 charges. So you need to think about the contribution from every single charge on Q2, right? Because we are thinking about Q2. So that means you need to think about 3 forces: this pair, and also this pair, right? So let's write down or draw the force at least. So let's start with Q1 and Q2. Let's start with this pair. Q1 and Q2, they are opposite sign in terms of the charge. So they attract each other. So that means Q1 will have the force pointing that way. Q2 will have the force pointing that way. Right. But in this case, we are not really concerned ourselves with the force on Q1. So we can just ignore the force on Q1 because that's not what the question is asking. So I just draw only Q2. And again, it's along the line joining them. So I have this force here. Let me zoom in a little bit. So what should I label this one? This one is F on 2 by 1. So it's going to be F21, right? It's pointing that way because they are attracting each other, 1 and 2. Now let's do this pair, Q2 and Q4. 2 and 4, they are also opposite sign in terms of the charge. So they attract each other, but they are attracting each other along this line, right? So F, in this case, is going to be F24 because it's F on 2 by charge Q4. And it's pointing that way because 2 and 4 attract each other. Are we done here? No, because we also need this pair. Q2 and Q3, now this is something different. They have the same sign, which is negative. So they repel each other. And they repel each other along the line joining the 2 charges together, 2 and 3. So along this red line. So repelling each other means the force on Q2 is pointing this way. This is F23. Are we done here? Well, yes, because we have accounted for all the forces from every charge other than Q2. Okay, so this is kind of like a simple kind of thing that you can realize right away from the beginning is that other than Q2, how many charges are there? Well, 3, 1, 2, 3. So the number of force that you need to draw or write down has to be 3. Okay, so if you draw only 2, then you know you're missing 1. Okay, now actually this is kind of like halfway done because the remaining thing to do is to add these 3 forces together. You have to again add them like you add vectors. So I'm gonna redraw the diagram here because it's easier. So I have this Q2. Q2 is pulled down by 4 that way, by 1 that way, and then by 2, 3 that way. And then we have to add this together. Okay, and now comes probably a little bit, difficult part in terms of mathematics because, you need to do components and anything. So I hope it's clear to you that this angle here is 45 degrees because it's a square. And I also hope that it's clear to you that F21 and F24, they have the same magnitude. Is it clear or not? Well, F21, the magnitude of F21 is equal to K Q2 Q1 divided by the distance square, which is 1 centimeter square. Right. It's the distance between Q1 and Q2. And F24 is K Q2 Q4 divided by the distance square. But this is side of a square, right? So it's also 1 centimeter square. And Q2 Q1 and Q2 Q4 is just 1 times 1, 1 times 1. So the magnitude is happen to be the same. Okay, maybe accidentally because I just chose the number to be this way. If Q4 is something different, maybe like 2 here, then Q24 will be longer and they don't have the same magnitude anymore. Okay, so just this kind of like the way I set it up. Okay, but in this case, they have the same magnitude, F21 and F24. So I can add F21 and F24 together first to get what we call F prime here. And because they are the same magnitude, right, the direction is also 45 degrees for F prime. And you can see that I chose to do it this way because F prime and F23 now point along the same line here. So the last step will be a lot easier than it should be. Okay? So let's just calculate quickly the value. So the value for F21, which is the same as F24, so we don't need to repeat it. So I'm gonna do this calculation. So I got this 90 newtons. Okay, you can check again because like you saw before that sometimes I got the calculation wrong, but hopefully not wrong here. So F21 is 90 newtons, F24 is also 90 newtons. And we're gonna need this in the end anyway. So let's just calculate F23, which is equal to K Q3 Q2 divided by, it's not 1 centimeter anymore, right? Because it's this distance here. And it's longer than 1 centimeter. It's actually square root of 2 centimeters from simple geometry. If you don't believe me, you can verify by yourself that is that. Okay? So again, this side is longer than 1 centimeter. Make sure you understand why that's the case. So I calculate this anyway. So Q3 is 2. That's the difference. Don't forget that you have different charges. Q2 is 1. And then divide by. Sorry, I recalculate this again. So 9 times 10 to the 9 times 2 minus 6 times 1 minus 6 divided by and actually I got the same number, which is 90 newtons. which should be, I think I chose it such that Q3 is a little bit further away. So it's actually weaker. So to make up for that longer distance, I make Q2 stronger in terms of the charge. Right? So in the end, they are all 90, 90, 90, like this. Okay, so let's go to the next page and then, really calculate this. So again, I have this force and green down, and then red one going that way. So I need to add these three forces together. This is 90 newtons from the calculation. I'm not going to do the labeling of the force F1, 2, F2, 3, or whatever, right, because it's on the previous page. And then this is 90 newtons. So we need to add this force together. So we add this one and this one first to get F prime. So F prime here is 90 newtons times square root of 2. Okay, it should be clear because it's just a right triangle, so it's the usual Pythagoras theorem, right? So 90, 90, you get 90 square root of 2. And actually this one I should draw it a little bit shorter because it's 90. Right, so, and then I add this one and this one together. So in the end, and this one is longer than that one, right? So in the end, the force is pointing this way. And the net force on Q2, which we call F2, is pointing that way. And the magnitude is equal to 90 root 2 minus 90, which is about 37 Newton, like this. Okay, if any step is unclear, please let me know, okay, because you're going to be doing this kind of problem for sure, I guarantee you, on the final exam. All right, so when you answer this, you need to say what's the magnitude, which we got here. And you need to say what's the direction. So there are two ways of doing. You can say it's 37 newtons and the direction is going that way in 45 degrees. This is fine. Yeah. So is this one add that one, right, in the end? Minus 90, right, because they point in the opposite direction. So you can answer it this way, or you can answer it in the component, right? So you can say it's minus 37 sine 45 degrees in the j direction, and then minus 35 degrees, 37 cosine 45 degrees in the I direction. Also like that, it's fine. But I mean, again, my point here is that you need the magnitude and you need the direction, right? So it doesn't matter how you say it. You have to say those two pieces of information together. Okay? So let me summarize again what to do. And you can try finding the force on different other charges, right? So again, the first step, and this way of doing things will be applicable also in the next lecture when we talk about electric field. This is for electric force, but electric field is very similar to what we just did here. Right? So it's a little bit more general. Any case, first you need to draw the correct direction of the forces. So go one pair at a time. So Q1 and Q2, that's the first pair, give you this one, right? So it's pointing that way. Instead of that way, how do you know? Because they attract each other. And then you go to the next pair, Q2 and 3, they now repel each other, so the force is pointing that way instead of that way. Okay? And then the last pair is Q2 and Q4, which is attracting still, so the force is pointing this way for Q2. So once you have written down or draw the three forces, the next step is to add them together, like you add vectors. So you need to figure out the magnitude of each one, and that's when you use the Coulomb's law here. Be careful that some of the charge will be further away. For example, Q3 here is not 1 centimeter away from Q2 because it's 1 centimeter times square root of 2. So that's why it's like this. And then different charges, okay, that should be obvious. Right? And in the end, you just need to add everything together. So that's what I did here. And in the end, my resulting force, which is from adding this force, and this force together, give you the resulting force to be that one. Okay, so be very careful when you do this. Conceptually, it's very easy. Okay, so I don't want you to miss this kind of question on the exam, and believe it when I say that some of you actually for last semester and more than half of you actually missed this kind of question, which I know everyone understands how to do it, but I mean, you just maybe temporarily forgot about how to add them. Okay, so I think that's all I'm gonna say for today. In the next lecture, we're gonna introduce another concept which is called an electric field. So I will see you on Wednesday. Unless you have any question, you can stick around and ask. If not, then have a good day and I'll see you later. All right, take care everyone.